The SpaceX Starship is a groundbreaking, fully reusable spacecraft designed to revolutionize space travel by transporting humans and cargo to destinations like the Moon and Mars. With an impressive payload capacity of over 100 metric tons to low Earth orbit, Starship aims to make deep space exploration more affordable and accessible than ever. Powered by advanced Raptor engines that run on liquid methane and oxygen, Starship is engineered for efficiency and sustainability, even enabling resource utilization on other planets. Its cutting-edge thermal protection system allows it to withstand the intense heat of re-entry, ensuring safe landings. Capable of carrying up to 100 passengers, Starship is perfect for a wide range of missions, from space tourism and scientific research to interplanetary exploration. It's set to play a pivotal role in humanity's push beyond Earth, including NASA's Artemis program for lunar landings and future crewed missions to Mars. As space exploration reaches new frontiers, Starship is at the forefront, paving the way for a bold and sustainable future in space. Whether it's establishing colonies on other planets or enabling commercial space travel, this spacecraft is a key step toward making humanity a multi-planetary species. Starport Mars is an ambitious concept for future Martian colonization, designed as a vertical village with a range of advanced technologies to support life on Mars. The structure features a docking port at the top, a ground-based research facility, and subterranean habitats, all playing a crucial role in the vision for human life on Mars. In the future, as interplanetary travel becomes more accessible and Mars undergoes terraforming, Starport Mars will facilitate frequent travel between Earth and Mars. The docking port will accommodate spacecraft, while space elevators will transport passengers down to the research facilities and further into the underground living units. This vertical design not only optimizes space, but also ensures that every part of the settlement is interconnected, creating a sustainable and efficient living environment. The tower's self-sustaining ecosystem is a key feature, with potential for expansion through modular, interconnected units. Cutting-edge technologies like 3D printing robots, nuclear fusion power, and space farming will be essential for making this vision a reality. Starlink Internet represents not just an advancement in technology, but a significant step toward a globally interconnected society. The system's design leverages cutting-edge innovation to solve one of the most pressing modern challenges, ensuring equitable internet access for people across every corner of the globe. As the network grows, its reach and impact expand, promising to revolutionize how we think about connectivity, access to information, and economic empowerment. At the heart of Starlink's mission is its ambitious vision of creating a global network of networks. This involves a seamless integration of thousands of satellites that work together to provide high-speed internet access to places where traditional infrastructure like fiber optics or cellular towers cannot reach. These satellites communicate with each other through advanced laser technology, enabling data to travel quickly across the globe without the delays often associated with older systems. This interconnectivity ensures consistent and reliable service, even in the most challenging environments, from mountaintops to deserts and even over oceans. One of the remarkable features of Starlink is its adaptability. The network continually evolves with the deployment of more satellites and the introduction of new technologies. For instance, as demand increases, additional satellites can be launched to improve network capacity and reduce latency. Furthermore, the modular design of the Starlink receiver allows for upgrades, ensuring users benefit from ongoing improvements without needing to replace their equipment frequently. This adaptability highlights the service's commitment to staying at the forefront of technological innovation. Starlink's impact extends beyond individual consumers to industries and governments. In agriculture, for example, remote areas can now utilize advanced tools like drone monitoring and automated irrigation systems, which rely on stable internet connections. For businesses, reliable internet access allows remote operations, facilitating global trade and commerce. Governments and nonprofit organizations can use Starlink to bring essential services to underserved areas, bridging the gap between urban and rural communities and fostering inclusivity in education, healthcare, and public service delivery. For disaster response and humanitarian aid, Starlink's capability to provide instant internet access is a game changer. When hurricanes, wildfires, or other natural disasters strike, traditional communication networks are often among the first casualties. Starlink's portable satellite-based system can be rapidly deployed to provide immediate connectivity, enabling rescue operations, coordination of relief efforts, and real-time updates to affected communities. This capability has already been demonstrated in several disaster zones, underscoring its potential as a critical tool in crisis management. SpaceX has also addressed one of the primary concerns associated with satellite networks, their impact on astronomy and the environment. By implementing sunshades and low reflectivity coatings, Starlink satellites reduce their brightness, ensuring they do not interfere with astronomical observations. Additionally, the company adheres to strict end-of-life protocols, designing satellites to deorbit and burn up completely upon mission completion, reducing the risk of space debris. The economic implications of Starlink are equally profound. By providing internet access to areas previously cut off from the digital economy, Starlink opens up new opportunities for entrepreneurship, education, and innovation. Small businesses in remote locations can now compete in global markets. Students can access online learning platforms, and communities can participate in the broader digital ecosystem. This democratization of access levels the playing field, fostering a more inclusive global economy. As Starlink scales up, it is also pushing the boundaries of affordability. While the initial costs of equipment and subscriptions are higher than traditional options, the economies of scale and advancements in manufacturing are expected to bring prices down over time. Additionally, SpaceX is exploring partnerships with governments and organizations to subsidize costs for the most underserved communities, ensuring that the benefits of Starlink's technology reach those who need it most. Looking to the future, Starlink's potential applications are vast. Beyond Earth, the technology could play a pivotal role in enabling communication for missions to the Moon, Mars, and beyond. As humanity ventures further into space, reliable and fast communication systems like Starlink will be essential for exploration, research, and eventual colonization efforts. The technology could also support global scientific collaborations, enabling real-time data sharing and analysis for projects that span continents or even planets. In essence, Starlink is more than just an internet provider. It is a catalyst for transformation. By breaking down barriers to connectivity, it empowers individuals, strengthens communities, and drives global progress. As the network continues to grow and innovate, it stands a testament to the power of technology to create a more connected and equitable world. With Starlink, the dream of universal internet access is not just a possibility, it is becoming a reality. Starlink Internet is transforming the way the world connects by utilizing an innovative satellite-based system that provides global internet coverage. This revolutionary technology, designed by SpaceX, aims to bridge the digital divide and bring high-speed, reliable internet to even the most remote corners of the planet. The Starlink constellation comprises thousands of small satellites orbiting in low Earth orbit, meticulously arranged to ensure uninterrupted service to residential, business, and mobile users. Setting up Starlink is remarkably simple, which makes it accessible to a wide audience. Users need only a receiver dish, a power source, and an unobstructed view of the sky to connect to the vast network. The receiver automatically aligns itself with the satellites, eliminating the need for technical expertise or complex installations. Despite its simplicity, the technology behind Starlink is highly sophisticated, employing advanced phased array antennas and satellite beamforming to ensure consistent, high-speed connectivity with low latency, rivaling many traditional terrestrial broadband services. Starlink's appeal lies not just in its technical capabilities, but in its mission to connect those who have historically been left behind by traditional internet infrastructure. In rural and underserved regions, where wired or fiber optic networks are impractical or economically unviable, Starlink provides a vital lifeline. It empowers remote communities by offering reliable internet access for education, healthcare, business, and personal communication, thereby unlocking opportunities that were previously unimaginable. Farmers, for instance, can now leverage internet-based tools for precision agriculture, while students in isolated areas gain access to online educational resources and virtual classrooms. Healthcare facilities in these regions can connect with specialists around the world, enabling telemedicine and improved patient outcomes. Although Starlink is more expensive than many traditional internet providers, its value proposition lies in the accessibility it delivers to areas where such connectivity was once unattainable. The service is particularly impactful in regions affected by natural disasters or crises, where terrestrial networks are disrupted or entirely destroyed. Starlink's rapid deployment capability and resilience make it a critical tool in emergency response efforts, enabling communication and coordination in the aftermath of calamities. The technology is also advancing the possibilities for mobile users and industries requiring connectivity on the go. With the integration of Starlink into vehicles, ships, and planes, seamless internet access becomes a reality, regardless of location. This capability is transformative for sectors like shipping, aviation, and logistics, allowing operations to continue efficiently in even the most remote or isolated settings. Starlink's broader implications extend beyond individual users and businesses to the realm of global communication. By democratizing internet access, the service contributes to reducing inequality in digital literacy and economic opportunity. It fosters a more interconnected world where information, innovation, and collaboration can flow freely across geographical and socioeconomic barriers. As more people gain access to reliable internet, the ripple effects on education, entrepreneurship, and social development are profound. The challenges associated with deploying and maintaining such an extensive satellite network are immense, yet Starlink continues to push the boundaries of what is possible. The constellation's design minimizes latency by maintaining a close proximity to Earth, with satellites orbiting at altitudes of just 550 kilometers, compared to traditional geostationary satellites that operate at 35,000 kilometers. This proximity not only enhances performance, but also facilitates faster satellite replacement and upgrades as technology evolves. Additionally, Starlink has addressed environmental and astronomical concerns through thoughtful design choices. The satellites are equipped with sunshades to reduce their visibility from Earth and minimize interference with astronomical observations. They are also built to be fully demisable, ensuring they burn up entirely upon re-entry into Earth's atmosphere at the end of their operational life, thereby mitigating the risk of space debris. As Starlink continues to expand, its impact on the global connectivity landscape becomes increasingly apparent. It is not just a technological marvel, but a transformative force, breaking down barriers and enabling countless possibilities for communication, commerce, and social interaction. By making the internet truly global, Starlink is reshaping the digital frontier and paving the way for a future where connectivity is a fundamental right, accessible to all. The XPeng X2 is a revolutionary electric vertical takeoff and landing (eVTOL) flying car developed by XPeng Aero HT, a subsidiary of the Chinese electric vehicle manufacturer XPeng Motors. As a part of the rapidly growing field of urban air mobility, the X2 stands out as a symbol of futuristic transportation technology. With its sleek, teardrop-shaped design, the X2 offers not just a visually striking aesthetic, but also an efficient aerodynamic profile that enhances its performance in the air. This design, combined with cutting-edge materials and advanced technologies, positions the X2 as a game-changer in the world of personal and urban air transport. The vehicle's construction is a masterpiece of engineering, with an emphasis on minimizing weight without compromising safety or durability. The internal structure is made from aeronautical-grade aluminum, which provides strength while keeping the overall weight manageable. The exterior shell is crafted from carbon fiber, a material known for its lightweight yet robust properties. This combination of materials not only contributes to the X2's exceptional flight performance, but also ensures that the vehicle is highly resistant to the stresses of flight, ensuring long-term reliability and safety for passengers. One of the most exciting features of the XPeng X2 is its design as a two-seater, which makes it ideal for urban mobility. As a fully electric vehicle, the X2 is particularly well-suited for urban environments, where pollution is a significant concern. It is envisioned to serve primarily as an air taxi, offering a sustainable, emission-free alternative to traditional road-based transportation. The X-2's electric propulsion system means it produces zero carbon emissions during flight, contributing to efforts to reduce urban pollution and offering a cleaner, greener option for urban transport. Beyond its role as an air taxi, the X2 has the potential to be used for a variety of other applications, including sightseeing tours and medical transport, further expanding its versatility. The X2 offers a premium travel experience with an emphasis on both performance and passenger comfort. It supports both manual and autonomous flight modes, making it accessible to a range of users. In manual mode, a trained pilot can control the vehicle as they would any other aircraft, providing a sense of traditional aviation experience. However, the real innovation comes with the autonomous flight mode. With the press of a button, the X2 transitions into autonomous operation, allowing the onboard systems to take over and manage the flight, including takeoff, navigation, and landing. This mode offers a hassle-free experience for passengers, allowing them to sit back and relax as the vehicle's advanced intelligent flight systems work to ensure a smooth, efficient journey. These intelligent flight systems are at the core of the X2's autonomous capabilities. The vehicle's onboard systems continuously monitor a range of variables, such as weather conditions, air traffic, and the vehicle's own performance metrics, to autonomously determine the most efficient flight path. The system can adjust its course in real time, optimizing for speed, safety, and energy efficiency. This capability is particularly important in urban environments, where flight paths may need to be dynamically adjusted to avoid obstacles, other aircraft, or changing weather patterns. The autonomous navigation system also enhances the vehicle's safety, as it can instantly respond to potential hazards or emergencies. Inside the X2, passengers are treated to a cockpit designed for maximum comfort and functionality. The interior features a wide, unobstructed view, offering one of the most expansive panoramas available in its class. This is not only a luxurious feature, but also practical, as it allows passengers to enjoy the experience of flight from a new perspective. The instrumentation inside the cockpit is intuitive and user-friendly, with a design that evokes the feel of a spacecraft. Floating displays provide essential flight information with a sleek and modern interface that complements the vehicle's futuristic appearance. The cockpit's design prioritizes ease of operation, ensuring that even passengers who are unfamiliar with aviation can understand and interact with the controls seamlessly. The XPeng X2's power system is built around 4 independent battery packs that power 8 electric motors, which are connected to counter-rotating propellers. This arrangement offers impressive stability and maneuverability, making the X2 agile in urban environments. The combination of multiple motors and independent battery packs adds an extra layer of redundancy, enhancing the safety of the vehicle. The X2's batteries provide a flight time of up to 35 minutes on a single charge, which is sufficient for most urban commutes and short-range flights. With a top speed of 130 kilometers per hour, approximately 81 miles per hour, the X2 can easily navigate cityscapes, quickly covering distances that would take much longer by car. In terms of safety, the XPeng X2 is designed with multiple fail-safes and redundancy systems. One of the standout safety features is the multi-redundant system that ensures the vehicle can continue flying or land safely even if one or more rotors fail. This is crucial for maintaining the integrity of the flight in the unlikely event of a mechanical failure. In addition to this, the X2 is equipped with a ballistic parachute system that can deploy automatically in the event of an emergency, providing an added layer of protection for passengers. The parachute system is designed to bring the vehicle down safely in a controlled descent, minimizing the risk of injury or damage. The X2 is also outfitted with an extensive network of sensors, radars, and cameras that continuously monitor the vehicle's surroundings. This sensor array feeds critical data to the onboard flight computer, which processes the information in real time to optimize the vehicle's performance. Additionally, this data can be transmitted to a remote monitoring station, allowing operators or emergency services to track the vehicle's status during flight. This connectivity is part of the broader ecosystem that supports the X2, which can be integrated into a larger network of urban air mobility services. The ability to share real-time data enhances situational awareness, contributing to the overall safety of both passengers and other aircraft in the vicinity. Xpeng Aero HT's development of the X2 represents years of research, innovation, and dedication to creating a sustainable and safe alternative for urban mobility. The company's commitment to advancing transportation technology is evident in the meticulous attention to detail in the design and functionality of the X2. From its sleek, aerodynamic form to its intelligent flight systems and robust safety features, the Xpeng X2 is a prime example of the future of transportation. In conclusion, the Xpeng X2 is much more than just a flying car. It represents a new chapter in the evolution of urban mobility, combining cutting-edge technologies, sustainability, and safety to create a vehicle that could transform how we think about and experience transportation in cities. Whether serving as an air taxi, a sightseeing vehicle, or a means of medical transport, the X2 holds great promise in reshaping our approach to mobility in the coming years.